Today we're going to be talking about assessment 1.1.3, and it's to define three different types of systems. There's an open system, a closed system, and an isolated system. The way I'm going to do this is I'm going to hit one at a time and try and think of an example or two that goes with it. So the first system we want to talk about is the most common one we're going to see, which is all ecosystems are this, which is an open system. And what an open system means is that this system exchanges matter and, this is our key, and energy with its surroundings. So for me, I like to think of kind of like a forest. All right, so I'm going to scroll this down so we have lots of room to work with. I'm going to draw a picture, so bear with me. I'm not the most artistic individual. So what I'm going to start with is a tree, okay? And you guys know already that trees take in light. So I'm going to start with my tree. And I'm going to think about what's going in. So we have light energy going into our tree in our forest. Whew. Sorry, that looks kind of crazy. And then we have a process that happens here. We have photosynthesis. I'm just going to label with a P, mainly because I don't have the space to kind of write it all out. So we have a tree, and then we have photosynthesis happening. So we have light going in, and we're using our systems models with errors. We can make this a box or a circle, but I think having the drawing makes it a little more clear. And then the energy from this tree goes several different places. The most obvious one is, I like to think of a bug. All right, we have a bug that eats from our tree. I'll make him blue. All right. Bugs have 6 legs. My blob has 6 legs. All right, so this bug is going to take in the energy, and then it's also going to do an energy process with it. It's going to do cellular respiration. It's going to consume. So I'm going to label that with kind of C1. Then, of course, the energy from our tree that went to our bug is going to be eaten by a larger carnivore. All right, so our bug is also going to be eaten, and that energy is going to go to another mammal or larger animal. This is the best I can do, guys. You're going to go with it. And again, this animal, the energy that came originally from sunlight to the bug is again going to go to this, and it's kind of consumption too, where it's doing cellular respiration. So we have our kind of the easy flow, the logical flow that we learned in biology. We have our food chain here. You also have to consider all the other places energy goes. So our plants are going to give off heat. Our bug is going to give off heat, and so is our animal. So we have energy lost here. So our inputs have to equal our outputs. So our inputs, not all of it ends up here. It gets lost as heat. If we think of this as a forest with leaves, they fall. We have things that die. All right, so we have death. Our bugs die. We lose energy that way, and our animals die. So this is kind of the death energy flow, which I know is a little bit morbid. And all those dead things are going to end up as kind of detritus material. It's detritus material. And of course, that material gets broken down by, we all know, decomposers. So the energy from all the dead things is going to go onto our decomposers to continue our cycle of life here. Sorry, that was my phone if you heard that. So we have our decomposers. All right. Now, you're kind of looking at this and thinking this is a pretty much closed system. We haven't really gotten energy from outside, but you have to think about this guy. He's on legs. All right. So he does not have to stay in this ecosystem. So of course he's going to bring in food from elsewhere. So we've looked at the transfer of energy in this system, but you also have to think about kind of the transfer of materials. So materials are going to transfer again, and I just want to make sure I get this absolutely perfect for you guys. We'll do it in white. All right, so we have a transfer of materials. And the way I'm going to emphasize this is when things are broken down into soil, you have materials that leave all this dead stuff. All right, so you can think of the soil, the water, kind of the environment is storing these materials. So this is our storage / our like nutrient pool. I'm going to box that guy up. So we have our storage and our nutrient pool. And this is also going to leave, it's going to be exchanged with other systems around it because of wind or even water. So we've exchanged energy and we've exchanged materials with the system around it. And of course I didn't hit all of where the materials are transferred, but my goal is to make sure we kind of do an example in class so you guys can see that. If we keep going and we keep talking, that's our open system. And again, that's when materials and energy is shared with the areas around it. The other system, which is kind of our most logical one next, is a closed system. So our closed system, it exchanges energy but not matter. There aren't any realistic examples of a closed system, so there's no natural ones. But if you want to think about things like bottle gardens, or if you have an aquarium and you close the lid off, or it's still getting sunlight, it's still getting energy, but you're not sharing any things like oxygen and CO2. These are typically not balanced. We also tried to build one, like a city people could live in, and that was called the Biosphere 2. As you can imagine, there's plenty of issues, but the overall issues is it was not balanced, not enough food, and the O2 / the CO2, the ratios were just way off. There was no way to control them. It just took too much energy and there wasn't enough energy coming in. Some people like to think of the Earth as one. The Earth is a circle. Sorry, guys. And we have our continents. All right, so we have energy coming in from the sun, but we're not really, and we have energy leaving, right? So this is heat that leaves. But we're not really a truly closed system. So if white is our energy, we get stuff from space, okay? So we have meteoroids. Sorry. But we also send stuff like satellites and other space junk into space. So as close as we can get to a closed system is the Earth, but it's not a true closed system. The last one I'm going to briefly touch on, and mainly because there's none really in existence unless you think of the entire universe as one, is an isolated system. And you guys, I apologize for the handwriting. If it's hard to read, just let me know. And this is neither matter or energy is exchanged. So the only possible one is the whole universe. So if you were to take the scale all the way back to as big as it gets, that would be the only isolated system in existence. And that is topic 1.1.3. I come to class with these notes, and I will see you guys on Thursday.